All right, in this video, we are going to solve these polynomial equations by factoring. So let's take a look at the first example over here. We want to start by moving the 27x so that we have the other side equal to 0. And then we want to factor this. So I know over here I have a common factor of 3x. I'm left with x squared minus 9 equals 0, and then I can factor this further with difference of squares. That's x plus 3 times x minus 3. So my solutions over here are x equals to 0, x equals to negative 3, and x equals to positive 3. Three solutions for that first one. Pretty easy question there. Almost like grade 11 math with a bit of a twist, I guess. Guess technically you could consider that grade 11 math. Let's go to the second question over here. So again, I'm going to move these two terms to the left side. So we have 4x4 minus 24x squared minus 108 equals to 0. I always want to make one side equal to 0. Now a common factor here, I can common factor out of 4. I'm left with x4 minus 6x minus 108 divided by 4 is 27. Oops, there's a square here. So this can be considered a simple trinomial. It's just x4 and x squared. We want to find out what multiplies to negative 27 and adds to negative 6. So my two numbers are negative 9 and positive 3. So I can rewrite this as x squared minus 9 and x squared plus 3. And then this one can be factored by difference of squares, but this one cannot because it's a plus. It's going to be 4 times x plus 3 times x minus 3 times x squared plus 3. Now that it's fully factored, I can state my solutions. Over here, it's negative 3. Over here, it's positive 3. And this one will have no solution. So only two solutions for this second question over here. Let's go to the third question over here. In this third question, I could do synthetic division and factor theorem here, but if you notice 3 and 5 and 12 and 20, they kind of numbers are kind of similar in terms of multiples. You can actually factor this by grouping. So you want to split it in the middle. Over here, I'm going to factor out x squared, and I'm left with 3x. Well, actually, I can factor out x cubed. So I'm left with 3x plus 5. And over here, I can factor out negative 4. And I'm left with 3x plus 5. So grouping does work in this one, which means I'm left with, oh, I can actually take out an x here as well. Totally forgot to take out the common factor of x there. So now I'm left with 3x plus 5 times x cubed minus 4x. Then I can common factor an x out of this bracket. So I'm left with x, 3x plus 5, and then this turns into x squared minus 4. Then I can difference of squares this bracket, which is going to give me x plus 2 times x minus 2. Now that it's fully factored, I can state my solutions over here. X equals to 0. Complex factor there, so negative 5 over 3, negative 2, and positive 2. All right, let's go to this fourth question over here. Again, I can start by common factoring, and my largest common factor is 2x. So So I'm left with 5x squared plus 13x minus 6 equals to 0. That's a complex trinomial. I can factor with my man method. So that's negative 30 and 13. So it's 15 and negative 2. So now I'll do grouping over here. So 5x squared plus 15x minus 2x minus 6 equals to 0. I'll split it in the middle. Over here, my common factor is 5x, and I'm left with x plus 3. Over here, it's negative 2. I'm left with x plus 3. Then I can finally write it in factored form. 2x, x plus 3, 5x minus 2 equals to 0. So my solutions for this one are x equals to 0, x equals to negative 3, and x equals to 2 over 5. 3 solutions for this one over here. Let's go to the 5th question over here. Again, I can just common factor out only a 2 in this question. I'm left with x cubed plus 81. And now I can do difference of cubes on this. Or I guess sum of cubes since it's a plus. But can I cube root 81? No, it's not possible actually, because I can't cube root 81. So since I can't solve it by factoring, I'm going to solve it to try and isolate x because I only have an individual x term over here. So I'll start by dividing the 2 on both sides. Which just gives us x cubed plus 81 equals to 0. I move the 81 to the other side. Then I can just cube root both sides. So that's just x equals to cube root of negative 81. Now, there are ways you can simplify this. You can, for example, you can turn this into, well, we can bring the negative out first, because if you have an odd power, you can always bring the negative out. You can't do that with even powers though, although you can't have an even power and a negative number. There's just no solution there. Then 81, I can rewrite it as 3 times 3 times 3 times 3. And then I can take these threes out. Cube root of 3 times 3 times 3 is just 3. So I have a negative here, I have a 3, and then I have a cube root, and I only have 1 3 left in there. So if your teacher expects you to simplify cube roots, that would be the final solution for this one. If not, that would be an appropriate final answer. And let's go to the last question of this video. Again, I'm going to move this term to the other side to begin with. Then I'm going to just common factor out 2x squared, and I'm left with x squared minus 24. Again, I can't really difference of squares this, so I'm going to solve it in the same way that I solved this one over here. This is just, my solution is x equals to 0. Over here, it's going to be x squared minus 24 equals to 0. Move that to the other side, so x squared equals to 24. When I square root, remember it's going to create a plus or minus. Anytime you have an even root, it creates a plus or minus. If you have an odd root, it doesn't create a plus or minus. You just use the same sign as the other side. So plus or minus root of 24. And root of 24 can be simplified. Basically, I can turn this into 4 times 6, and then the square root of 4 is just 2. So plus or minus 2 root 6 if you're required to simplify. Radicals. So 3 solutions in this question: 0, positive 2 root 6, and negative 2 root 6. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.